Hello, welcome to Math 1960, section 301. This is Calculus 2, UNO Summer Session number 3. Today we will discuss parametric equation. We will discuss how to graph a parametric equation, find a rectangular equation, convert from parametric equation to rectangular and vice versa. So what is the parametric equation, or what is the how do we actually define a parameter? So suppose x is equal to x of t. So x is expressed in terms of t, and then y is expressed in terms of t as well, where t here is the parameter. It's the parameter. So that is defined within certain interval, call it I. And x and y also are defined within that interval. So then we say x is equal to x of t, y is equal to y of t. These two are parametric equations. Parametric equations are very useful for a curve, or for curve that are not for equations that are not functions. All right. So an equation of a circle does not meet the vertical line test. Some equations of parabola does not meet the vertical line test. This type of curve, or this type of equation that do not meet the vertical line test, we use parameters. So using a parametric equation make it easier on us to work on with this type of equation. So a parameter x would be expressed in terms of x of t, y would be expressed in terms of y of t. And so now we want to graph these two parametric equations. So the first thing is, here I have x is equal to 3t squared, and then I have y. This is y of t though. Y of t is equal to 2t. Okay, t varies from -2 to 2. So this is my t here. So here I have -2, I have -1, I have 0, I have 1, I have 2. So when we plug this in here, I'm going to have 4 times 3, that's 12. And then here I'm going to have 1 times 3 is going to be equals to 3, then 0, and then I have 3, and then I have 12. So when we plug this into this equation here, I'm going to have -4, -2, 0, 2, and 4. So now we can graph this function as follows. We can graph this curve. This is not a function, this is a curve. Graph. So here in my x, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So as you know here, -2, so -2 here. So here say this is -2, this is -1. All right. So here is 0. So -2 here is coincided with 12, and then -1 is coincided with 3, and then the same with 1 and 2. So it's going to look something like this. All right. This is my equation. It's going to look something like that. So since we start with -2 from here, so we're going to go like this. Okay. So a parametric equation, usually we use arrows that describe the motion. So this is how we indicate the orientation of the curve. So find a rectangular equation of the curve. Rectangular coordinates, which is x, y, and z. So if I have a, an equation that expressed in terms of t, we want to go back to x, y, and z. So since here this is like, so what I'm going to do, we have Pythagorean theorem, x squared plus y squared is equals to some number, right? So hypotenuse, right? Hypotenuse squared. So and then at this time, if we just said we know also that cosine square t plus sine square t, it's equal to 1. Okay, this is another thing that we can use as well here. So here I'm going to say cosine here is going to be x over r squared plus y over r squared. This should be equals to 1. That means, in other words, that x squared plus y squared is equal to r squared. And this is like a circle. This is going to give me a circle. So to do the orientation of this circle, we're going to go counterclockwise. Okay, here the radius here is r. The radius here is r. Okay, we want to find the rectangular equation of this. So rectangular, which is equation expressed in terms of x and y. So we use the same formula like before. So here we're going to say cosine squared, which is x over r squared plus y over r squared is equal to 1. That means x squared plus y squared is equal to r squared. This is for this one here. So that here, when we plug in 0 for this here, we're going to get r, right? In this equation, we're going to get r. When we plug 0 for this one here, we're going to get 0. And then, so it starts from r0. And then when we plug in pi for this one, we get a negative 1. And when we plug pi for this one here, we get a 0. So then my equation, graphing of that equation, it looks something like this. We start from here, so the orientation is start from there. Okay, so here negative r here, sorry, negative r. It's going to be negative r and 0, and here r and 0 for y. So, and then when we do this for this one here, we just going to get we're going to get x squared over r plus y squared over r squared. It's going to be equal to 1. That means x squared plus y squared is equal to r squared. And at this point, when plug in n 0 here, we're going to get a 0 for x. We're going to get r, and then the second point we're going to get a 0 again, and then we're going to get negative r. So then when we graph it, it's going to look something like this. So here 0 and r, and here 0 and negative r. and the orientation goes like this. It's x and this is y. This is x and this is y. So this is how you you graph a curve. So here we have a parametric equation. We want to find the corresponding rectangular equation from this. So here, if we're gonna choose our parameter to be t. So then if we say x of t is equal to t, then now y of t would basically equals to x squared minus 4. These are the two parametric equation of this. All right.